Hello everyone. Welcome back to the Mobile Computing lecture series. In the previous lecture, we discussed the introduction of course and overview. Today, we start with wireless communication fundamentals. This lecture is very important because it forms the base of the entire subject. If you understand today's lecture clearly, upcoming topics like signals, antennas, modulation, cellular networks, and GSM will become easy. Do not forget that you will be understanding this particular subject from scratch, even though if you do not have any telecom background. So let's begin. What is wireless communication? First, let us understand what wireless communication means. Wireless communication means transmission of information without using physical wires. Wireless communication means that we are sending some data without using physical wires. In wired communication, data travels through cables. In wireless communication, data travels through air using electromagnetic waves. So instead of copper or optical fiber, the medium is free space. Important point. Wireless communication uses electromagnetic waves, mainly radio waves and microwaves. Example may be mobile phone calling, Wi-Fi internet, Bluetooth headphones, satellite TV, GPS navigation. All this work without physical connection. So whenever you are communicating without cable, it is wireless communication. So these are the difference between wired communication and wireless communication. Next is need for wireless communication. There are several reasons why we need wireless communications. The biggest reason is mobility. Users are not fixed at one place. They move while talking on phone, using internet, traveling with GPS. Wires cannot support movement, but wireless can. Easy and fast development. To install wired network, digging, laying cables, maintenance, these are huge blunder. Wireless networks can be deployed quickly and easily, especially in rural areas, disaster zones, temporary setups. Cost effective for large coverage areas. For very large areas, laying cables is expensive. So wireless communication is needed, which covers large areas, uses fewer physical resources, supports modern applications, modern technologies like mobile internet, Internet of Things IoT, smart devices, all require wireless communication. That's why wireless communication is the backbone of mobile computing. Wireless communication or wireless transmission means sending some information from transmitter to receiver through free space. No wire is required. How does this happen? The basic idea or the key idea is electrical signal is converted to radio wave and then it is sent to through electrical signals. Again, let me explain step by step. Data is generated in electrical form. This electrical signal is converted into radio waves. The radio waves travel through air. At the receiver, the radio wave is again converted back into electrical form. This is the basic working of wireless transmission. Wireless communication system components are information source, transmitter, modulator, antenna, wireless channel, receiver. Now let us understand each block one by one. Data is generated at the transmitter. Data is modulated onto a carrier signal. Antenna radiates the signal. Signal propagates through air. Receiver antenna capture the signal. Demodulation recovers original data. This is how the basic working of wireless transmission. This is the block diagram of wireless communication system. First is input transducer or information source. This is where data originates. For example, voice from microphone, text data, video signal, any data, any message you can send. This is the input to the transmitter. Transmitter prepares the signal for transmission. It amplifies the signal, processes the data. Next is channel. Channel through which the data is transmitting. The data will be sending. Here we are having modulator. That modulator will modulate the signal. It combines the message signal and the carrier signal. Then that signal is passed through channel and it is given to receiver. Receiver basically have an antenna. That antenna converts that electrical signal into electromagnetic waves, radiates them from free space. Then the antenna will capture the signal, demodulates it, and passes or recovers the original data, then pass it to the output transducer. Output transducer will give that output to the circuit which requires it. There is an additional block that is distortion and noise. If some distortion and noise is added to the channel, then that distorted signal or noise signal will be removed through the receiver. The receiver purpose is to remove or to recover the original signal, to remove the distortion or to remove the noise. So receiver role is to capture the signal from the antenna, using antenna, demodulates it and recovers original data. Next is electromagnetic spectrum. Wireless communication uses a part of electromagnetic spectrum. The electromagnetic spectrum consists radio waves, microwaves, infrared, visible light, X-rays. Wireless communication mainly uses radio frequency. Different frequency bands are used for different applications, different range, different data rates. Frequency for radio transmission. Now let us understand frequency. Frequency means number of oscillation per second and its unit is hertz, that is denoted by Hz. It determines the speed and coverage of communication. Low frequency, longer range, lower data rate. Higher frequency, stronger range, higher data rate. This key relationship you should understand. That is why FM radio uses lower frequency. Wi-Fi and mobile internet uses higher frequency. Next is radio frequency bands. High frequency HF is high frequency, that is the range is 3 to 30 megahertz, used for shortwave radio. Very high frequency VHF 30 to 300 megahertz, FM radio and TV. Ultra high frequency UHF range is 300 megahertz to 3 kilohertz, 3 gigahertz, that is used for mobile phones and Wi-Fi. Super high frequency, the range is 3 to 30 gigahertz, used for satellite communication. This is the complete radio frequency spectrum. LF is low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extremely high frequency. Next is characteristics of radio frequency. Transmission range, bandwidth availability, noise and interference, ability to penetrate obstacles. These are the characteristics of radio frequency. Application of wireless communication. Cellular communication, GSM LTE, wireless LANs, Bluetooth devices, satellite systems, Internet of Things. So let us summarize today's lecture. Wireless communication enables communication without wires. Wireless transmission uses electromagnetic waves. Frequency selection is very important. Wireless systems are the foundation of mobile computing. So these are the summary, and in the next lecture we will study signals, antennas and signal propagation. Thank you for watching. See you in the next lecture.